Welcome you all. Today we are going to discuss about design and simulation of 4-bit adder using Verilog and which will be simulated in the Cadence nclaunch. Okay. So here we are going to do the simulation of 4-bit triple carry adder, and we know that for 4-bit triple carry adder, 1-bit full adder is the basic building block. First we should write the Verilog code for the 1-bit full adder. Then this full adder can be called n number of times in the triple carry adder. Since I'm writing here, it is for 4-bit triple carry adder. The full adder is called for the 4 times. Okay, and this is the corresponding test bench, for the 1-bit full adder. Uh, this can be explained in the class. Now let me move on to the how to simulate this with still programming in the Cadence. So go to the box and log into your students at Cadence website and give your password. Okay, so open your folder. So let me start with the new folder. So right click, new folder. Let me choose my folder name is experiment 7 underscore triple carry order. Open that folder and do right click and open a terminal. First I need to type the program for the triple carry as well as for the test bench. To type the program, just give this command gedit and your file name. My file name is RCA and file extension is .v. That is a Verilog. Now that will give you another new window. That is a text editor window where you can type your program. So like for example, module ladder like this. Okay. But as of now, for time being, copying from the source. So this is 1-bit full ladder. Copy this programming and I'm pasting here. Students must do. They should type and they should explore. They should not copy. And other one is triple carry add-on. You can copy the both of ladder and triple carry add-on and save it. Once saved, your file will be saved in the directory 2425 even sum experiment 7 RCA with the name of RCA.v. Once everything is completed, just you can close it. I can go back to the terminals once again. Now the Verilog file has been created. Now let me create the test bench file. So again to create test bench file, I'm going to create another testbench.v file. Let me name it as rca underscore tb.v. If I enter, it will open another new window where I can type the test bench programming. So this is a Verilog test bench. Here I'm going to add 0 plus 0. They are called as test cases, and 3 plus 5 and 15 plus 1 and so on. So let me copy this, and again students must should not copy. They must export and type the Verilog programming and save the file. Okay, now go back to your again your command sorry terminals. Now we can go for as usual tcsh, and you can open your path source underscore cadence so on. So now generally in the previous experiments we will open virtuosa, that is for the analog experiments. Now we are going to the digital experiments, that is nclaunch. That's a tool we are going to use. Now this is your work setup. Okay, and check your directory whether it is your directory. If not, you should go for your own directory. So my directory is home student 2425 even 7 experiment 7 underscore RCK. So just open this, select this directory. After selecting a directory, go to the file, set design directory, where again you should choose your own path. That is your working directory. My working directory is experiment 7 underscore RCA. Once if the directory is selected, create the cds.library file. It will ask you to configure the CDS library file. Okay. So here simply we are going to do the Verilog programming. So just we are going to include all the default libraries to call all the keywords or the other functions, other inbuilt functions. Just give OK. That is include default library. Click OK. Once if it is clicked, your work lib has been created here. Now look at this. Work lib has been created. Okay. Now there are three steps in your process, in the simulation process. The first step is compilation. Second step is elaboration. And third step is simulations. Okay. First, we should do the compilation of both testbench file as well as the Verilog file. Click on your Verilog file, that is a source code, and do compilation. You just look at this. It is launch Verilog compiler. Just click on this, and the console will give you the information. If there is any error in the program, that will be indicated here. Okay. Now I compile the rc.v file without any errors. Now let me do the compilation of the test bench. So click on the test bench file and do the compilation. Again, this is also working properly without any errors. Okay. Now after do the compilation, just go and check it out to the work library. Now the file has been created here. Okay. So my file name is header underscore 4-bit. That is my module name. And the other test bench module name is tb underscore adder 4-bit. Okay. So now I'm going to simulate the test bench code. Am I right? So click on this tb underscore adder underscore 4-bit and go for the elaborate. That is the second step in the simulation process. Okay. Only if you click on this icon, this will be enabled. And just click on this. Yeah, again, the console will give the information about the process. If there is any red line in the console, that represents error in the elaboration. If not, we can proceed for the further state. So once after elaboration is done, now let me go for the simulation window. So to take the simulation window, go to snapshots and click on your work lib tb underscore add, that is your module name. Once if you click on this, the third icon will get enabled. Click on this work lib. Now you can look at this. Your simulation icon has been enabled. Just click on the simulation. Now that will redirect you to the simulation window where we can able to see our outputs in the form of waveform. Okay, fine. Now let me look at the design browser window where I'm going to. So just click on this and do right click. And since we are going to see as a waveform, just let me send this module to the waveform window. So right click, send to waveform window. Okay, now the waveform disk has been created. Now we need to run this file to show the outputs. So just you can have the run button here. Just click on this run button. And now you got your output. Now look at this. So I given 0 plus 0. Now look at your Verilog code in the test bench. The first case is A is also 0, B is also 0. Okay. Now look at this, A is 0, B is 0. Therefore, sum is also 0. If you look at the second test case, it is A is equal to 1, B is equal to, sorry, A is equal to 3, B is equal to 5. Input carry is equal to 0. So which means 3 plus 5, 8. Similarly, this is 15 plus 1, 16. So 16 means 1, 0, 0, 0. So your C out will be 1, your carry will be 0. And this will be continuing. Now similarly, you can, if you want, you can change the test vectors which is mentioned in the test bench programming. You can verify your results. So this is the sum of the test case I given, and this is a simulation window. Thank you.